objective of today, pretty straightforward, similar to what we've done with our other solids. We are going to be finding surface area and volume of spheres. And then definitely looking at some applications using those, okay? We've said it all along. We are so beyond, here's the formula, just straight up find the surface area. We're so beyond that, okay? We need to be able to use that in some problems. All right, I'm going to have you watch a couple of little short YouTube clips similar to what you did last time. But before we get into that, I want to talk about what a sphere is in general. We have a fixed point, which we call the center. Okay, fixed point, which we call the center. That's in the very middle or center of your sphere. What a sphere is all of the points that are the same distance away from that center point. Okay? The sphere is all of the points that are equidistant from that center point. And that's in every direction. Okay? It's not just this way, that would just be a circle. So think about all of the points in every direction that are equidistant from that center. What we call the radius, this is the same as the radius of a circle. Bless you. This is the distance from the center to the edge of the sphere. Distance from the center to the edge of the sphere. So the surface area of a sphere is equal to 4 of those circle areas. Okay, well, would you agree circle area is pi r squared? Times 4 of them. Okay. If you want to make your own video like that, I'll give you extra credit. But it has to be similar to that, and I would prefer a little audio too. It can't be that one, you have to do it yourself. No, like. All right, so when we are going to actually find the surface area of a sphere, like the directions say, we're going to write the exact and the approximate answer. Remember, if it says exact answer, that's in terms of pi. So start with your formula. Surface area equals 4 pi r squared. Bring down the 4, bring down the pi. This is pretty basic here. We're given everything we need, which is the radius is 2 inches, so plug that in. Two squared is 4 times 4. This is 16 pi inches squared. And then we want the approximate answer to the 100th. So then you can go ahead and multiply out your 16 times your pi. Bless you. And we should be getting 50.27 for our approximate answer. Go ahead and try the next one on your own. Alrighty, for the second one, we can bring down our 4 pi. Our radius is 4, so square that. Lauren, what is your exact surface area?
201.
Your exact.
Oh, 4. Wait, what do you, oh, no, like in pi you're asking? 64. Yeah. What?
I want you to say it.
64 pi.
Thank you. Well, I had a 64, I had somebody else saying pi, I want you to tell me. And then what is your approximate answer?
201.06 inches squared.
All right, thank you. Okay. Pretty straightforward here. All right. So notice what we've done in these first two examples. The radius of the first one is 2. The radius of the second one is 4. So we doubled the radius. But what happened to the surface area? It did not double. What did it do? It quadrupled. Okay? So don't think just because you double the radius that the surface area doubles. Okay? The surface area actually quadrupled. Number 3 says the circumference of the great circle is shown. The great circle just means around the outside of the sphere. Okay, so we are told the circumference of that is shown. The circumference of that is shown. We have to find the surface area of the sphere. Knowing the circumference, what information can we get that we need? R. So circumference of a circle is 2 pi r. We can take the circumference that we know, substitute that in for C. And then we can solve for r, which is what we need to be able to find the surface area. If you have a pi on both sides of your equation, those can cancel out. And then all we need to do to solve for r is to divide both sides by 2. Which we end up with the radius being 6.9. Once you have that, then you can use that to find the surface area of the sphere. Go ahead and just leave this in terms of pi. Sorry, I couldn't find a good one for you that would make sense. The surface area one makes sense. Okay, you may have seen and remembered the volume formula is 4/3 pi r cubed. And you can see from that screenshot that the reason why is pretty difficult. So, yeah, we'll just accept this one. Okay. Again, all you need is the radius. But you are going to cube the radius in this one. For these examples, same thing. We'll write the exact and the approximate answer rounded to the 10th. Notice on the first example, though, what are you given? The diameter. So we need to take half of that to find the radius. Half of 18.2 is 9.1. Make sure you use that for your radius. I do have a suggestion on how you entered this in your calculator, if you're curious. Do it with me if you want. I would do the 9.1 to the third first, hit enter. Multiply that by 4, hit enter. Divide it by 3, hit enter. And you should have gotten, oh, I don't have the exact answer. What should you have gotten?
1,004.76.
1,000 what?
1,004.76.
1,004, okay. 0.76, and that's pi millimeters cubed, okay. And then if you go ahead and multiply that by pi, I have that this is 3,156.55, yeah? All All right, Colton, what did you get for your exact answer?
I got 645.33 pi.
Do we agree with that? 644.33 pi? We don't agree with that? Okay, Colton, try this again on your calculator for me. 22 to the third, hit enter.
Oh, that's what I did wrong.
Okay. So, Mark, you were shaking your head. What do you have?
Wait, I don't know, 14,197.3.
What was it?
14,197.3.
Pi?
Yeah.
Do we agree with that?
Yes.
Okay, good. And then the approximate answer that I have is 44,602.24 centimeters cubed. Do you like that?
Yeah.
Okay, good.